Thank you so much for joining us. My name is Jeff Nepper with Canary Labs, and this webinar will highlight how to integrate the Canary system with Ignition applications, specifically when there's multiple sites in an enterprise solution. My role with Canary is I serve as Executive Director of Business Development, and I've had the joy and pleasure of working tightly inside of the Ignition community with some amazing Ignition partners, integrators, and end users for the last 5 years. Before we tell you about how you would want to integrate Canary into Ignition, I think it's important we address the why. Why consider putting a Canary Historian or a Canary system alongside your Ignition solution? Well, the first problem that we hope to help you solve is long-term scalable performance, essentially future-proofing your projects. And we believe that Canary's NoSQL Historian is part of that answer. And the reason is that a single Canary Historian can scale to more than 2 million tags with very high speed write and read performance. And that's not a number that just happens in the beginning. The secret sauce to the Canary NoSQL Historian allows for that long-term performance, despite how many years of data you store or how many hundreds or thousands or millions of tags you store. The read and write performance stays the same long-term. Additionally, the data compression algorithm that Canary uses in the actual historical archive is a true lossless data compression. So if you're writing values today and you're recording tags at 1 second scans and they're changing every second, 8 years from now, 10 years from now, you still have all of those original 1 second polls and all of those changes recorded. There's no interpolation. There's no swing door algorithms being used for compression. And it's because of the performant nature of the historian that we do not have to shrink the database essentially in order to maintain that performance. And finally, the historian really does a good job of simplifying the data collection from multiple sites, keeping it local for site use, as well as replicating it to an enterprise architecture. But in addition to solving that problem, the power of our why is that there's some other benefits you can pick up, such as the ability to build on top of the work you've already done in Ignition with your UDTs, or taking your basic parent-child folder tag structure and translating that into asset models inside of Canary. Once those asset models are built, you can create new calculated tags based on assets. We can define events based on asset conditions. And most importantly, that data does not stay siloed inside of Canary because we can feed it back into Ignition as live tags, as well, of course, as tag history. And then an additional benefit on the reporting and analytics side, Canary has a tool called Axiom that is an HTML5 trending dashboarding and reporting tool. And it really enables the self-serve reporting style that most users are seeking. It embeds inside of Ignition because it is all done in HTML5. And there's a really nice feature of templating assets. So I can design for an asset type like a pump, and then my design gets replicated based on the number of pumps that are inside of the system. So I design one time for one asset and then it replicates. All right, so let's talk a little bit about basic site architecture before we move over to the enterprise architectures. I want to give really high praise to the way that the folks at Inductive Automation have set up their system. They really are truly database agnostic, giving you the option of what you want to use for your historian. So by creating the Tag Historian module that Ignition offers, what they're really doing is giving you the ability to take all of the work that you do inside of your Ignition project. And when you say historize a tag, you can create a data feed via the Tag Historian module API. Canary's been able to read that API and essentially present itself as a native historian to Ignition, the same way that you can choose to use a Microsoft or a MySQL database instance or a Postgre instance. You can also choose to use Canary as an instance. And that's not just for logging data, it's also recalling data via that same Tag Historian module API. So you get to choose what you want to use for your database, but you maintain the same functionality as if you were using a SQL database. So if we just consider Canary as being a standalone server on your Ignition site, and then with multiple sites, feeding that data also to an enterprise instance of Canary. So if we dive into what that actual integration looks like first on a site configuration, let's take a look at those Ignition servers, or that Ignition gateway server and the Canary server. So on the Ignition gateway, we will look to install a module that Canary has built that will work with the Tag Historian module so that we can feed data over to the Canary instance. That module is available right now, has been for the last 2 years on Ignition's module showcase. It's free to download. There's no licensing required. And all you need to make that work is the Tag Historian module from Ignition. That module gets installed on the Ignition gateway alongside the Canary sender service. And the sender service is essentially the front half of Canary's store and forward. So the sender ultimately communicates to the receiver service to log the data into the historian. In order to configure the module, I need to do 2 different configuration parts. The first part is to establish the module as a storage provider or a collector. The second piece of configuration is to establish the module as a tag history provider back to my Ignition project. So as a storage provider / collector, I am logging data from Ignition to Canary. And as a tag history provider, I am reading data from Canary back into Ignition. So if I'm logging data to the historian, I essentially just need to create the connection from sender to the receiver. When I configure that collector inside of my Ignition gateway, I'd give it a name, and this will become my storage provider name that I'll recall later on. I tell it where the historian is that I'd like to target, what is the name of the server, and what data set do I want to write the data to within Canary. A data set is nothing more than a folder structure inside of Canary at the highest level for tag storage. Then from my Ignition project, I simply edit my tags. I enable my history to true. I select the storage provider that I have named inside of my gateway configuration for the Canary module. And then I configure all of my history properties as needed. So do I want a deadband? What's my sample mode? What's my min or max time between samples? All of that is respected as part of the logging session because of that tight configuration through the Tag Historian API. It's just as simple to read data back from Canary. All we have to do is connect the module to the Canary Views service. And the Canary Views service is the single endpoint for reading data from the historian archive. So our data loop goes Ignition gateway to module, module to sender, writing to receiver, receiver writes it into the historian archive, and then I read it through views back through the module, back to my Ignition project. So all I need to do is configure a provider on my gateway. I name my provider. I tell it where the historian is located. Once I've done that, then as I'm using a vision project or now a perspective project, I use tag history. I browse my Canary instance. I find the tag. I set the properties as needed. So we handle through the module the different aggregation methods that Ignition provides. We can do real time. We can obviously do different historical periods, even powering things such as Perspectives Power Chart With the new UI for tag history browse in PowerChart, again, we can expose any Canary historian as a native tag provider. Additionally, if I don't have a UI, like in some perspectives instances, I may not have a tag history UI or tag picker. We can also just provide the tag path. And so I can pull directly from the tag path through the historian. If I'd like to embed Axiom's trending tool inside of Ignition Gateway, I can do that also. All I need is the web browser component on the gateway, and I call directly the URL of the Axiom machine or the Axiom core on my Canary server. So with Axiom embedded, I have the power to pass both duration of time and tag list through the URL that I'm calling. So I could place a single Axiom instance at the front of on my web browser, and I could script different URLs based on the action that's been taken on my Ignition project. Additionally, Axiom has some really nice interfaces. If you've had a chance to use it before, then you know how easy it is to add tags and to change data around inside of that tool. And if not, I'd encourage you to look at our website and get a sense of that. All right, let's shift now that we've covered the bases of the site and talk about how we do more with this on an enterprise level. So with sites reading data to a local Canary instance, or maybe even not, maybe there's no reason to send data to Canary's instances on local site. Perhaps you only want to historize that data at enterprise. Either way, every site is going to have a Canary module on the gateway, and that Canary module will point either to a site historian, to an enterprise historian, or to both. Once I've collected those site tags and I've moved them to an enterprise historian, then within Canary, I can create an asset model. That asset model will provide information to our calc server so you can build calculations. All of the new data that I've created inside of Canary, I don't want to silo it just in Canary. So we can use the Canary Publisher service to provide a MQTT Spark plug feed back into Ignition via the Cirrus Link distribution and engine modules. So not only can I feed back to the enterprise gateway new tags and new information that's been built inside of Canary, especially using MQTT, I can easily push that the whole way back down to my site gateways as well. So what's it look like to configure data to multiple historians? It's as easy as adding a comma and a second server name. So when I'm creating my data collection inside of the gateway and I tell it where the historian is located, I put my site historian name, comma, and then my enterprise server name or IP address. All of the data transfer within Canary's sender to receiver, which is what's happening. Our sender service is targeting multiple Canary receivers. Wherever you tell it the historians are, there's a receiver there. That connection between sender and receiver uses TLS for all data transport. So these are independent streams that get created. So I could be writing data locally to the site with an independent stream writing to the enterprise. It is outbound only, secure, encrypted, and very lightweight in transport. Additionally, with the data coming to my enterprise historian, I can contextualize that data. So as I mentioned, we can create asset models. These asset models allow you on the backside of your tag archive in the historian. So we write the historian the same way to the historian. We write the tags the same way they appear inside of your Ignition project. But on the backside of that archive, we can create multiple virtual views of that archive, meaning that you can create essentially a translation layer between the client and the archive that will allow for tag names to be changed or aliased, tags to be grouped and referred to as assets, assets to be grouped into parent-child relationships, and I can also read additional metadata from other SQL databases. So if I wanted to add to the Canary asset model information about maybe my maintenance history on an asset, or perhaps in oil and gas, I might want to tie a reservoir engineer who's responsible for this well to the asset. I can do that by reading existing SQL databases elsewhere in my organization where that data is already probably available to me. Once I'm also referring to my tags as assets, then I can create calculations inside of the Canary Events and Calc server. I create a calculation one time, assign it to an asset, and then it replicates for every instance of that asset. So I can very quickly take something that might be a pump with a flow and take a tag that is a 30-second sample of a flow rate on a pump and understand every 30 minutes what's my average flow been since start of shift, what is my total flow been, and even start to sort my assets based on things like condition-based rules. So if flow for current 30 minutes is more than 15% lower than last 4 hours, create an event. These events get captured in a SQL database of your choice. So I can write those events directly back into my Ignition project simply by reading that SQL database. And then finally, I mentioned before, Axiom allows for very fast asset templates. I can now embed Axiom inside of that enterprise application, which gives me the ability to do asset sorting, condition-based asset monitoring and visualization, and most importantly, create workflows that automate the reports that my users are looking at based on urgency or based on their own priorities. Then I mentioned that the Canary Publisher service allows us to feed all of this data back to Ignition via MQTT Spark plug. That live stream recognizes my asset structure. It pulls in all of my calculated tags, any type of Boolean that represents an event alert. I can push back and provide to Ignition, not as tag history, but as an actual live tag via the Cirrus Link modules. All right, so the demo that I'd like to show you with the time that we have left and then save some time for Q&A is I'm going to just walk through briefly what it looks like to do these steps and just show you the tools inside of Canary and show you the actual configuration pieces. So be thinking as we go through this, any questions that you'd like to have answered at the end. We'll save 5 minutes for Q&A. Let's go ahead and get started. All right, so the first thing I want to show is my project. So in my project, I've got a series of pumps that are assigned to stations and some towers on each of these stations. And as you can see, I'm already historizing that data and I'm sending it over to my Canary instance. So I've got 5 stations in total. Now, right now, if I come into my designer, come into my gateway, the Canary module's already been installed. And here is the collector that's currently been configured. So I've named it Bear for Bear County, which is where we are right now, down in San Antonio at the watch party. And this is named Bear Demo. I tell it where is my sender service, which is always going to be local on my Ignition gateway, what port I have open for that. Because I'm local, I'm not worried about using credentials to on the security side of this for moving the data to my sender. The sender to receiver security is already handled, and that's addressed inside of Canary system. I tell it where is the server or the IP address that the sender needs to send the data to the historian, and then what is the name of that data set. So I'm already sending it to my local site historian, which is on my own machine called JNEPR. But if I also want to send it to a enterprise historian, I just put in the comma, tell it the name of the machine, in this case, the address of the machine. So now that stream is going to both my historian local, as well as a second independent stream going up to this server, Canary Hist 1, Canary Labs Online, which happens to live in AWS. So if I use Splashtop, let me log into that. And here's hoping that Splashtop will show up through a Zoom webinar. I didn't check that. So thumbs up for me if it if you can see this. But if I open up the Canary Historian admin tool over here on AWS and look at my historian, what I expect to see is a data set called bear. There it is. If I look into it, here's today's file, and there's all of my Ignition tags currently logging. So configuration literally is just a matter of adding that server name. And so I could do that to as many different historians as I'd like. I could be sending this data multiple places all at the same time. All right, so now that the data is in to the historian, just to kind of show you the configuration of reading that data, there's my provider. I've named it. I've told it, let's refer to the Canary database for tag history as site historian. Where is site historian? Site historian is on this machine that I'm doing my demo from. And so if I wanted to say, maybe bring in a Spark chart, when I look at tag history, there's what it would look like if I was using a SQL database. Here's what it looks like if I'm using Canary. I browse my nodes inside of Canary, browse right down through. There's the data set called bear. Station 1, pump, flow, state, all the things, all my tags. And then I can choose to how I want to configure that, because the module allows for all of the properties or parameters that I would normally use inside of Ignition for one of these controls. Even if I want to pull it, we'll pull it every 5 seconds. And we'll put it into play. Might help if I pick a tag that has some, there's the history. Lots of history on that one. 15 minutes is probably a bit noisy. Maybe I should do a interval. So let's ask for every 1 minute inside of that interval. There we go. Better sparkline. But you really can't tell whether you're using Canary's historian or the SQL historian, because the integration is just that tight. Okay, so now let's talk corporate side. If I pop into my Canary historian instance for my corporate server, and I look at my asset model, what we've done is we have taken all of the tags that are being logged on Ignition for the bear demo, and we've grouped them into a asset called Canary Water, which is my company. And there's the water district bear. And then I've got 4 other counties around Texas that I'm also representing. This data is coming in from other Ignition sites, if you will. So here on the enterprise, I'm able to understand that I've got a water district. Inside of a water district, I've got stations. Inside of each station, I have pumps and towers. And pump 1 has these tags. Now, some of these tags are calculations that we've built. Once I've defined my pump and what the tags are that are in a pump, current, flow, and state, then I can come over to the Canary calculation server. I can build a, here's an example of a flow calculation where I say, find all of the assets that are labeled pump. Every 5 seconds, create a new calculation. And here's the expression for that calculation. I want to use the delta bounds, OPC aggregate. I want to read the flow tag on my pumps, and I want to look for 10 minutes worth of history and calculate the delta bound in that 10-minute period. So it'll do that every 5 seconds. I output that tag back to my Canary server into a new data set called pump calcs, and then I deploy it. So I write one expression, I deploy that, And now it goes and backfills and picks up all 57 of my pumps back through the backfill time period that I had selected. And now that is live. I'll turn on my other calcs and we'll get those going. Now they're all live. And all of that data can now be sent out via my publisher. So my publisher essentially targets my MQTT distributor module, which is here local on this site. I'd have to, if I was on a different machine, I'd typically change this. I've got security disabled, but I could just as easily call 8883 and provide username and password. So I will show up as a unique client to distributor, and I will be publishing under the group ID Canary, node ID publishing, and device ID service, all of which I could configure. So if I turn this on, I connect, 181 tags that are on my calc data set are now being published. And when I come over and look at the MQTT engine, there's my pump calcs. I'm feeding data back as a live tag information. There we go. So let's just bring over our good old LED display, and I can take my flow calc and drop it right in there. So now I'm feeding history and I'm feeding live tags that have been created inside of Canary all at the same time. All right, I think we should go ahead and move over some Q&A. There's obviously a lot more that we could dive into, but this is just a little 30-second teaser to get your ideas flowing. So let's take a look at the questions that have come in. All right, Levi asked, the custom events sound perfect for conditional alarming in Ignition. Are people using it this way? Yes, absolutely, Levi. So that is really the power of us writing that back to a SQL database, is that you could read the SQL database for all of those events. And I should also mention, those events are more powerful than just saying, hey, look, Boolean true or false. We record the start time, the end time, we calculate the duration, and give you the ability to create your own custom properties during that duration. So if you wanted to, in my case there with the pumps, if I wanted to understand every time a state changed on the pump, I could create an event for that. But during that duration, I might also want to know what was my average flow, what was the delta on my vibration, what was the average flow on this pump compared to the average of another tag. So you've got over 70 functions you can call. Great question. And additionally, I should say, I mentioned, right, then I could also create a alert tag, publish it via MQTT, and then trigger another action. Doug asks, the Canary module supports over 1 million value changes per second with Ignition, greater than 1 million value changes per second. No, Doug, actually the module itself isn't going to support 1 million updates per second. The Historian can, but each module feed, so think of an Ignition gateway with one module. Each gateway can read via the module approximately 40,000 updates per second. So if you had a site gateway that you needed to historize more than 40,000 updates per second, that's where we're going to switch back over to more traditional OPC logging sessions. The module is using connecting Web API to Web API, which is never going to be as performant for very large data flow change or data rate changes as OPC. Good question. Paulo asked, can the Canary module achieve the same self-aware that you can do with MQTT plus SparkPlug as shown in previous webinars? So Paulo, I don't know that I completely understand the question that you're asking as far as the situation that you're describing, but let me do my best for you. So the module is using essentially the web API of the tag historian to push data into Canary Sender. The sender and the receiver are aware of each other's states. So if for some reason the module is no longer sending data to the sender, the receiver knows, therefore, if the receiver knows, the admin knows. So yes, we are aware of the state, but the module does not pass a last will and testament the way that Sparkplug B does. So I'd ask you, shoot me an email, Paulo, if I believe this is Paulo that I already know. But if not, info@canarylabs.com. I'd love to do a follow-up with you. And then last question, Bradley asked, I'm confused. Is MQTT required for this to work? Great question, Bradley. No, it's not. So you do not need MQTT modules to read history from Canary back to Ignition. Ignition differentiates between a tag history and a live tag. So if you want to read the tags from Canary back into Ignition as live tags, yes, then you need MQTT modules. If you just want to pull history from Canary into Ignition, you only need, at that point, you only need the Canary module to do that. All right, everyone, thank you so much. Listen, if you'd like to learn more, or if you'd like to contact me for a one-on-one, info@canarylabs.com. Would love to help you out. Please tell us about your projects and tell us how we can help. Thank you so much.